like ABC union 2 3 equals ABC 2 3 2 3 5 union 3 5 7 is equal to 2 3 5 3 5 7 equals 2 3 5 7. Here we can see ABC union 2 3. In union we have to use the common elements one time, and also we have to include the elements, the rest elements which are not common, like ABC union 2 3. Here ABC and 2 3 are totally different, but we have to combine all the elements using one element common. So here there is no any element is common, so A, B, C and including 2 3 are the elements of this set. And like 2 3 5 and 3 5 7, here 2 but 3 is in common, so we have to take 3 one time, like 3 here. Same 5 is common, but we have to take 5 one time, and same 7 here. So 2 3 5 7 are the final elements of this set, this union, this. And using the diagram, Venn diagram, you can simply locate the position of elements. Like here we have two areas. One is the bounded region of the blue, and the second is the bounded region in red. So here 2 3 5 are the elements of set A. I am using this first set by A, and same 3 5 7 are the elements of set B. So here 3 5 are the common elements, but in union you can see 2 3 5 and 7. If we are combining both the sets, then 2 3 5 7 are the elements of this set of union. Like for the intersection operator, for sets AB, their intersection A intersection B, this is the inverted symbol of union, is the set containing all elements that is simultaneously in A and in B. Formally, for all AB such as A intersection B belongs to X, such as X belongs to A and X belongs to B. Note that A intersection B is a subset of A and it is a subset of B. For all AB, A intersection B is a subset of A and A intersection B is a subset of B. In the previous example, you can simply identify the intersected value. Like here you can see 3 5 are the intersected value, means the common value in the two given sets. So 3 5 is the value of intersection of this set and this set. So now here ABC and 2 3. So here ABC and 2 3 both are different and no any element is in common. So we can simply say phi is the part of this set, because the common element is only null set, that is phi. So we can simply identify this set by phi. Same 2 4 6 here and 3 4 5. I think 4 is in common, so there are no more than one element. 4 is only the element of this set A intersection B. So here 4 is the only set. Like in the Venn diagram, we can show here 2 4 6 like this and 3 4 5 like this, and we can see 4 is only the common element in both the sets. So here we can say 4 is the set of the element A intersection B. Now this is for disjoint sets. Two sets AB are called disjoint, that is unjoined, if the intersection is empty, like A intersection B equals to phi. Example, the set of even integers is disjoint with the set of odd integers because there are no any common elements in both the sets. So we can simply see by the figure there are many points of disjointness here. 1 2 3 4 1 2 3 4 and 5. So in these points the sets are disjoint.